Good afternoon to you viewers and subscribers, and welcome to another video. And in today's video I am going to be talking about step footing. Now, step footing is primarily used on land that are slope. So if you're building on a land that is slope, the appropriate way how to go about doing your footing for that structure is to step your foundation. And the reason why it is more appropriate to step your foundation or step your footing is because, let's say for example, the land is sloped like this, right? So you do not want to place your block work on that land like this, right? You do not want to place your block work on your land like this, because what you are going to end up with is a slanted wall. So your wall is going to go up like this, right? And that way it is not appropriate. So you would rather want your wall to go up vertical like this, right? Right? So you want your wall to go up vertical like this on your slanted land. And in order to get your wall to go up vertical like this, you will have to step your foundation. So stay tuned and I'm going to show you how that is done. In carrying out your step footing, the first thing you would want to turn to in your plan set is your wall footing detail. And you're going to turn to your wall footing detail to observe the depth of your footing, the width of your footing, and the thickness of your footing. In this case, the depth of your footing is 3 feet, the width of your footing is 2 feet, and the thickness of your footing is 9 inches thick. Now, when it comes to step foundation, the thickness of your footing is very critical. And let me explain to you what I'm talking about when it comes to the thickness of your footing. Now, to pour your footing on a step on a slope land is going to take more concrete than if you're pouring your footing on a flat surface. And the reason for that is that you have to start out with a thickness of your footing that is higher than 9 inches. So in doing that, you're going to find out that to pour that particular footing on that slope, it is going to take some more concrete to do so than if you're pouring on a flat piece of land. Now, your thickness of your footing is 9 inches. Now, I have seen where builders on site start out with the thickness of their footing on a slope land to be 8 inches. In other words, they use the 8 inches block to step their foundation. And I'm saying that is not right, because when you start out to step your footing with a 8 inches block, already you're below the thickness of your footing of 9 inches. So it is better to start out significantly higher than this 9 inches, and then when you level and get your 9 inches, that is where you step your foundation. And the reason why I've used 16 inches for my starting point is that you have to go up in increments of 8 inches, because the concrete block that you use on site is 8 inches high. Now, to use this 8 inches template, this 8 inches template is what we call a bulkhead. Is a construction term that we use to divide a vertical height between two different sections. So the bulkhead is 16 inches in height and 24 inches in width, because the width of this trench is 2 feet. It is 2 feet, right? So whatever the width of your foundation, that is supposed to be the width of your bulkhead. So let me get into the presentation now of telling you how to go about stepping your foundation. So you're going to excavate your trench at a 3 feet depth, and that 3 feet depth is going to be consistent throughout the slope of the land. So you're going to excavate 3 feet right along the slope of the land. After you have excavated your depth of 3 feet and your width of 2 feet, right, you're going to put up your first bulkhead. And your first bulkhead is going to be 16 inches in height. Then you're going to put a nail here, or you could have someone hold the car line on top of the bulkhead here, and then you're going to level this line, right? Ensure that this line is level, right? And it's leveled right back to the slope of the land, right? So after you have done that, you're going to take the tape measure and you're going to measure the vertical distance below the level line, and anywhere you get your 9 inches, that is where you're going to step the foundation. So you have your 9 inches here, and you step the foundation 16 inches in height. Then you level your car line here, right back to the slope here, and you measure the depth of the distance between the line and the slope, and wherever you have your 9 inches, you step again up 16 inches, and then you repeat the process. You level this line here. Wherever you get your 9 inches, you step your foundation up 16 inches, and you go across here, and you level this line. And you continue that process until you have reached the end of your footing. Now, the reason why 16 inches, as I said to you before, so you want to have at least 2 block heights. So 16 inches is going to be equivalent to 2 block heights. So your block work is going to be placed on top of the level concrete. So all this would be your concrete. And then you're going to place the blockwork on top of the level concrete. So that is how you step your foundation. If you do not do it that way, you're going to end up with your wall being sloped like that. And you want your wall to look something vertical like this. So from here to here is 16 inches. Then you're going to lay your blockwork again. 2 rows of block. So this is going to be 2 rows of block. So this is going to be, you lay your blockwork again. And this is going to be 2 rows of block. And you notice that this block height level with the top of the concrete here, and then you can continue with your vertical blockwork. With your vertical blockwork. So the step foundation is going to look something like this. So that is your step foundation with your blockwork placed on a level platform. And a cross section of this, if you should cut a section through this, a cross section, that is what you're going to see. So you're going to see the depth of your trench, which is 3 feet, and your width of your footing, which is 2 feet, and you're going to see your bulkhead here. This is your bulkhead, and you notice beneath the at the bottom of the bulkhead to the bottom of the step footing is 9 inches, which comes back to your 9 inches thick. And one thing before I move to the next section, I want to point out to you that you're going to start to pour your concrete from the base, from the bottom of the hill, going upwards. You should never pour your concrete from the top and let the flow go down. You pour your concrete from the bottom and until you get all the way to the top of your slope. But ensure that the bulkhead that you have placed right here, ensure that you put 2 steel pegs behind it. Steel pegs to reinforce the plywood that forms your bulkhead. Because what is going to happen as you start to pour the concrete going up the hill, the hydrostatic pressure in the concrete is going to be maximum here. And you don't want the weight of the concrete to push over the bulkhead here and cause the bulkhead to topple over. So you reinforce it with the steel peg so that that does not occur. I have stated to you earlier about the thickness of your foundation as it relates to step footing, that the thickness of your wall footing is there to resist against what is known as punching shear. Now, if the footing is not thick enough to carry the weight of the wall and the load of the building, the wall itself is going to punch through the thickness of the wall footing if it is not thick enough. And I'm going to shed some light on that further in the presentation for a brief moment. Now, what I've seen on site in regards to this 9 inches, and I think that it's a bad practice. Some builders, when they set up the bulkhead here, they level the line right across here to the slope, and wherever the line level and hit the slope, that is where they step the foundation. That is where they step the foundation. And I'm saying that is not correct, because at the 9 inches point here, as you start to go up the hill towards this point, you're going to reduce the thickness of your concrete to less than 9 inches. So you're going to move from 9 inches to 8 inches to 7 inches to 6 inches until you get to this point of 0. And that's where some builders or some workers on construction sites step the foundation on that slope line. And that is not right, because what you're going to do is you're going to put your blockwork on top of this portion here, which is less than 9 inches. And that part of the foundation is going to be subjected to cracking under the weight of the building, especially if you're doing a 2-floor building or you're doing a split level building with 2 additional floors on top of your split level. And a split level in most cases is when you're dealing with lands that are slow. So I'm saying that practice should not happen. And what you have is this. So that is your 16 inches bulkhead. And here is your 9 inches. The minimum thickness of your wall footing. So as you start to move from this point going up the hill, this 9 inches is going to reduce until it gets to this point of 0. So when you place your block work on top of this, this part here, this portion here, is not going to be able to deal with the weight of the building because the concrete there is not thick enough to carry the weight of the structure. And what you're going to end up with, you're going to end up with a cracked foundation. And that is going to even crack the wall also. The wall is also going to be cracked due to the crack in the foundation. And this situation is very tedious to deal with, and it is virtually unfixable, if not impossible. Because what you have, remember now, when you pour this portion, when you pour the concrete here, you're not going to be able to see the side. So you have to dig from the inside of the building and the outside of the building to get to this part here, to underpin this part here. And then you have to fix the wall that is cracked. Probably on the exterior and the interior, inside and outside, you would find that crack to be so structural that it crack both on the inside and on the outside. And that is going to be very expensive to deal with. And you do not want to encounter a situation like that. So I'm imploring you that do not build on this portion here, because it is less than 9 inches. And if it's less than 9 inches, it is not going to be able to carry the weight of the structure, and you're going to end up with structural cracks in your building. I am going to explain to you what is meant by punching shear, and I'm going to show you an example of what punching shear looks like. And before I do that, I'm going to explain to you how we arrive at the width of the foundation and the thickness of your foundation. So the width of your foundation is 3 times the thickness of your wall, which works out to be 18 inches or 1 foot 6 inches. Now, I usually make my width of my foundation 2 feet, and the reason for that is that when you spread your footing wider, it causes less stress on your foundation soil. So the wider your footing, the more stable your structure. And that is why I spread my foundation 6 inches wider than the average 1 foot is 6 inches to give the building more stability. Now, I must point out to you from a design perspective, that this 1 foot 6 inches is the minimum width. It can be more, but not less, because the width of your foundation is dependent on the soil's bearing capacity. The weaker your soil, the wider your footing to accommodate for the weakness of that soil. So I just want to point that out. Now, the thickness of your footing is 1.5 times the thickness of your wall, which works out to be 9 inches. And again, this is the minimum thickness. It can be more, but not less than 9 inches if you're using a 6 inches wall. And this is an example of what a punching shear looks like. If you notice, the weight of the wall punch through the thickness of your footing, and that occurs when your thickness of your footing is not thick enough to carry the weight of the structure. So the weight of the structure is so much that the thickness cannot deal with it, and the wall is going to punch through the footing, and that is what we call punching shear. And in the case of the step footing, as I've indicated to you before, this is the situation I'm talking about, where you're going to end up with crack in your foundation, because the thickness from your 9 inches point here coming up the slope is going to reduce and you do not want to place your wall on concrete that is less than 9 inches thick, because you're going to end up with this situation here, punching shear, and that is going to cause shear failure in your concrete, because your wall is going to move down while another part of your wall is going to remain stable, and that is what we call shear failure. So you must avoid that at all times. And this is critical to know when you're dealing with step foundation, because this situation does not occur immediately, and at times it do not occur during the construction phase. It occurs like a month or two or even years afterwards, when the building is occupied, and you have to take into consideration that you have spent a lot of resources to build that structure. You put in your porcelain tiles or your ceramic tiles, you paint your building, you put in beautiful windows, and to go and have to correct structural cracks in your wall is going to be very expensive, because you're going to have to replace all those things that you have initially. So that is it for this video. I hope you find the video interesting. I hope you have find the video informative, and if you like the video, please hit the like button. Do remember to subscribe, and I will see you in another video upload. Thank you.